Hi guys, this is meant as a really brief introduction to probability, and we've really been doing the work for probability already and thinking about counting up how many different, in terms of counting, thinking about how many different options we can have. Let's look at an example of this. If we imagine that K is the number of ways of having a success. So a success is like what we want to have happen. For example, like probability of rolling a 2, getting a 2 would be a success. And A is the number of ways of something happening. Then the probability of K happening is just the number of ways that K can happen divided by the total number of ways that something can happen. Okay, we're going to re-say this in terms of formal set language and then look at an example. So, using the same idea in set language, if K is the set of all successful outcomes and A is the set of all possible outcomes, then the probability of K happening is just the cardinality of K. So how many ways we can get a success over the cardinality of A, which is how many ways something can happen. Okay, now imagine rolling a 6. So K is how we can have a success, and the only way we can have a success is if we roll a 6. And A is the set of all possible outcomes. Well, all possible outcomes with a die would be 1, 2, 3, 4, 5, 6. So the probability of rolling a 6 is just the cardinality of how you could get a 6 over the cardinality of how many things you could roll altogether, which is to say 1/6. Well, what if we have two independent events? Independent events meaning that the outcome of one does not influence the outcome of the other. If I have two independent events, roll a 6 twice. So I've got one die, and I roll it, and then I roll it again. What's the probability that I get 2 6s? Well, clearly the die doesn't know its past history. It doesn't know if it was a 6 before. And we've actually done these diagrams before. You know, the probability, sorry, rather, the set K, which is the number of ways I can get a 6 twice, is just the set of 2 6s. So here there's just one element in the set, and that element is a set, which is 2 6s, 6 6, like the first die and then the second die. And all outcomes, well, I could write out all the outcomes, but there are a lot. But we've already figured out in past problems what would be the cardinality of something happening. So this is like any combination. So the cardinality of anything happening is just there are 6 things that could happen on the first dice or die or first roll, and then 6 things that could happen on the next roll. So 36 things could happen. So therefore, the probability of getting 6s is just the number of ways that I can get 2 6s, which is just 1, over the total number, which is 36. But what we can see is this is just, with two independent events, it's the probability of getting 1 6 times the probability of getting another 6. 1/6 times 1 6. So therefore we can come up with the expression if, let's say, if event 1 and 2 are independent, the probability of 1 and 2, so 1 joint 2, so the probability that both happens just equals the probability of the first thing happening times the probability of the second thing happening. All right, that's it.